That's great. That's great. Okay, now one thing is you, because we will be talking about mathematics, so you should have paper and pen with you because I will be showing you everything on slide. I will be discussing with you, and simultaneously you have to solve it. That is the only thing which you people have to do right now. As far as mathematics is concerned, I will be telling all the procedures, but solution has to be made by you by your own handwriting. I will be sharing the screen with you. You will be in a position to see everything. Now tell me whether the screen is ever, you can see the screen or not. Okay, okay, fine. First of all, we will discuss what our syllabus is, what we are supposed to study. Now, this is your complete syllabus of this paper. There are four blocks. Block one is for algebra, that is determinants, matrix one, matrix two. We will be discussing this part today. Later on, we will be moving to mathematical induction. Then we will move to sequence and series, that is in your block 2, algebra 2, complex number, equations, inequalities. In block 3, we have calculus without trigonometry. Differential equation that consists of differential calculus, application of differential calculus, integration, and application of integration. In block 4, that is something a little bit difficult. That is vector 1, vector 2, 3 dimension and dimensional geometry 1, and linear programming. Now, I'm not aware of how many of you have studied mathematics in your plus 2 level. Everybody has read it, or some of them have read it. Just let me know how many of you have studied mathematics at your plus 2. How many of you have studied mathematics at your plus 2 level? Nobody has read it. Nobody has read mathematics earlier in plus 2 level. Okay, a few of them have studied. Okay, fine, fine, fine. No problem. Nothing to worry. Now we will be starting your determinants. Here it comes. Determinant basically is a square array of numbers symbolizing the sum of certain products of these numbers. This product has to be done by a method. Many complicated expressions can be easily handled if they are expressed as determinant. Now, what determinant is? As I said, determinant is an array of numbers. You can see over here, this is a determinant form, which consists of elements in column and elements in row. The vertical line, vertical elements, yani ki this one is the column and these are the rows. That means this is a 2 by 2 determinant matrix which has 2 rows and 2 columns. This one is column 1, this one is column 2, and this one is row 1, and this one is row 2. Normally what happens, determinant is a number. How we will get this number and where it is used, that means where determinants are used, why they are used. So first of all, determinants are used to solve linear equations. Now question arises, what linear equation is? Linear equation is an equation in which the variable has a maximum power of 1. If the power is 2, it is quadratic. If power is 1, it is linear. You can see that here are two equations. Variables are x and y, and the constants are a, b, e, c, d, f. Now, what we do to calculate the value of the determinant? We just pick up the coefficients. Coefficients are those numbers which are always written in front of the variable. Here in equation 1, you can see that it is A. A is the coefficient of x. B is the coefficient of y. C is the coefficient of x. And D is coefficient of y. These equations are in their standard form. We just pick up these coefficients A, B, and they are written in that order only. Keep one thing in mind, don't change the order. They are, yes, please. What is your question? Please ask your question why you have raised your hand. You have to pick up the coefficients in the same order in which they are given in the equation. I have written it A, B, C, and D. Now, how to calculate this determinant? We just multiply A and B in this order, top to bottom cross, top to bottom cross in this diagonal line. We multiply A and D minus C and B, A and D minus B and C. This is the value of determinant. Now, you can see there are different methods how this is performed in a number. Suppose we have a 2 by 2, order 2. Order 2 means 2 by 2. 2 by 2 determinant, we have to calculate its value. Simple is that A into D minus B into C or C into B. That doesn't make any difference. I'm taking two examples of it. Try to understand it, what I mean to say why I've taken these two examples. And what is the difference between these two? 3, 5, 1, 3. I will be multiplying. I will be multiplying 3 by 3 minus 1 into 5 or 5 into 1. That doesn't make any difference. This is 3 minus 3 is 9 minus 1 into 5 is 5. 9 minus 5 is 4. Now, in this example, what I'm doing, I will be doing the same thing. 3 into 3 is 9 minus. Now, here you can see it is minus. So, that minus will be written like this. Minus 1 into 4. Minus into minus is plus. So, what I will be getting 9 plus 4. That is 14. Now, matrix determinant of order 3 by 3. That means there will be three equations and three variables. Three equations and three variables. You can see over there. Three equations and three variables. I have to simply pick up the coefficients of these numbers. Coefficient A1, B1, C1. Same order in which they are given. A1, B1, C1, A2, B2, C2, A3, B3, C3. Now, how this is a very tedious method. Try to understand. I have written the result of it. Now I will let you know how that is calculated. I am audible to you? Okay, fine, fine,
Yes,
fine,
but your
fine,
voice
fine.
is low.
Sorry? Okay. Now see, this is somewhat tedious exercise. How we have to calculate it. How this determinant will be opened. This is the result, the answer. Now the question arises how we got this. Now we will see how we got this. See to it. This is the matrix. This is the determinant. Okay, what I did. What is the method of doing it? Listen to it very carefully. Just pick this element, A1. A1 will be written over here. Now remove this row and this column. What is left? You are left with these four elements. These four elements will be written like this only. No change, as it is. First one is plus, second one is minus. No changes of this method also. Minus, pick this element, remove this row, and remove this column. You are left with B1, B3, and C1, C3. B1, B3, C1, C3 in matrix form. First one is plus, second one is minus, third one is plus. Now pick this element, A3. Remove this, remove this. You are left with these four elements, B1, B2, C1, C2. Here. Now, how I told you how to open it. Write this A1 over here as it is. Multiply top to bottom diagonal. B2, C3 minus B3, C2 or C2, B3. That doesn't make any difference in it. Close it with the bracket. Now pick this minus A2 bracket B1, B3, B1, C3 minus B3, C1 bracket close plus A3 bracket B1, C2 minus B2, C1 bracket close. When you will be opening this, when this is opened, you will get this. The better you have to understand how this we got. Okay, now a practical example of it. You have to calculate the matrix, this value, determinant of this matrix. What I will do now, I will do it direct. Pick this one bracket minus 1 into minus 4, 4 minus 4 into 3 is 12 bracket close minus 2, first one is plus, second one is minus bracket, remove this, remove this, multiply this 2 and minus 8, minus 4, you will get minus 8 minus 4 into 4, 16 bracket close. First one is plus, second one is minus, third one is plus. Now see, this is minus 3. I have to write this in minus bracket, minus 3. Bracket, remove this. 2 into 3 is 6, minus, since this is minus, so that will become plus. 1 into 4 is 4, 6 plus 4. Open it up, 4 minus 12 minus 8, here it is. Minus 8 into 1 is minus 8, minus 2, and 8 plus 16 is 24 with minus sign. Minus 24 into minus 2 will be plus 48. This is plus 48. Minus 3 plus 10 minus 30. This comes minus 30. Now leave this, add these, 3 and 8. 30 plus 8 will be 38 with minus sign, and then subtract it. 48 minus 38 is 10. Now the question is, Should I repeat it once again, or this opening of this determinant is clear to you? Should I repeat? Because this is the basic thing what you will be doing in determinant and when you will be solving. Because we will be using this concept in two applications. Okay, okay, no worry. Just a quick revision, I will be repeating it. This is the matrix, it's for all. This is the matrix, and you have to determine its value. Its value is known as determinant. What I will be doing, I will be picking this element. I will be writing over here this determinant. Remove this row and this column. You are left with these four elements. Pick these four elements and write it over here. Okay. First one is plus by convention. Second one is minus. Pick this element minus of A2. Determinant. Remove this row and this column. You will be left with B1, B3, C1, C3. B1, B3, C1, C3. Okay. First one is plus, second one is minus, third one is plus. Plus of this element, A3, determinant. Remove this row and this column. You are left with B1, B2, C1, C2. B1, B2, C1, C2. Now, next step is write this A1 bracket. Multiplication diagonally cross. This multiply. B2 into C3 minus B3 C2. Here. Close this bracket. Minus of A2. Minus of A2. Bracket. Diagonal multiplication. B1 C3 minus B3 C1. Bracket close. Plus A3. A3 bracket B1 C2 minus B1 C1 B2. Okay. This is what you have got. Now, here the application is. You have to determine the value of this. Let's pick one bracket. This multiplication minus 1 into minus 4, 4 minus 4 into 3, 12. This is complete. By convention, first one was plus, second one is minus, minus 2. Okay, bracket. Remove this and remove this. You are left with this 2, 4 and 4 minus 4. 2 into minus 4 is minus 8. Minus 4 into 4 is 16. Here it comes. First one is plus, second one is minus, third one is plus. Now you have minus 3 over here. So place this minus 3 within brackets. Next bracket, remove this element, this element. You are left with this. That means 2 into 3, 6. Minus 1 into 4. That will become plus 4. So here it is, plus 4. Open it up. Minus 8 into 1 is minus 8. minus 8 minus 16 will become minus 24. Minus 24 into minus 2 will become minus 48. Plus, when you will be multiplying this into this plus into minus, it will become minus. 6 plus 4 is 10. That will become minus 30. Add these two, keep subtraction sign, and subtract 48 minus 38. That will become 10. Now it is clear? Okay, okay, okay. Now it comes again somewhat tedious. Have a look at it, how it is written. But this is the basic method, the procedure, the way you have to solve it. This is the problem. 2, 5 minus 3, 4 minus 1, 5, 3, 6, 2. How to calculate its determinant? Pick 2. Remove that 2, 5 minus 3 and 2, 4, 3. You are left with minus 1, 5, 6 and 2. That will come in matrix form. Second one, first one is plus, second is minus. So it will become minus 5. Okay. Then remove that, remove this row and this column. You are left with 4, 5, 3, and 2. Here it comes. First one is plus, second one is minus, third one is plus. Plus into minus because it is minus 3. Put it in a bracket. Remove this and remove this. You are left with this. 4 minus 1, 3 into 3 and 6. Now, how to solve it? Raise this to diagonal multiplication top to bottom. Minus 1 into 2 is minus 2. Minus 6 into 5 is 30. Close the bracket. Minus 5, diagonal multiplication. Diagonal multiplication 4 into 2 is 8. Minus 3 into 5 is 50. Bracket close. This plus into minus is minus 3. Bracket 4 into 6 is 24. Minus into minus is plus. It will become 3. Plus. Simplify it. Minus 32. Minus 7. 27. Multiply this will become minus 64. Plus minus into minus is plus. 7 into 5 is 35. Minus 81. Add these and subtract this. You will get minus 110. Is that clear? This is the exact method of solving the determinant problem. Okay. Now, this comes with the same thing. Now, this comes with variables. Now, something other than numbers. Now you can see 1 A B C, 1 B C A, 1 C A B. I have to calculate the determinant value. How I will see. Go through the solution and just let me know which is that part which is now not understood by you. See to it, I have removed one step because I have taken this problem over here. Later on, today only, we will be solving similar problem by a different method. That time I will tell you why I have not done this thing over here. Because here I am just explaining you how determinant is found when numbers are not there. This step is clear to you? Anyone who has not understood this step? Okay. This can only be understood if you have paper and pen with you, because we are not understanding or discussing anything related to theory, because this is now mathematics and a pure applicative form. The more you write, the more it will be clear with you. Now tell me, how many have understood this step? I have deliberately removed a step between this and this. I've straight away written this. How many of you can tell me this is correct or incorrect? Nobody has understood how this came.
Sorry, teacher. We was studied in Afghanistan, which when a determinant have the row or the column will be same. The determinant answer is zero.
Continue. What are you saying?
Teacher, we was studied about.
Just a minute, madam. Where it is same?
Okay.
Where it is same? In which?
One.
No, no,
This is the first.
just a minute. Just a minute. I tell you. If that column is 111, if any other column C2 or C3 is 111, then only the determinant value will be 0. I will be discussing. Don't worry. That is very good. I'm happy that you remember. That is the application property of determinant. I stated that is why I said.
Yes,
Just have
teacher.
a look why I'm asking you to open it. When I will be talking about matrices, I will be just finishing this problem in 2 steps. And we will get the same answer.
Okay.
Nothing, no, that's very good. But my basic concern is you should understand it.
Okay, thank you, sir.
Now, has anybody other than ma'am can tell me how this we got it? I'm talking about this part. No, nobody can tell me. That means. Okay, I tell you the shortcut. Yes, please.
Okay, sir. Thank you. Should I explain all of them?
Of course, you can do it.
Okay. As you taught us, when the first one, for example, A, number one, when we want to determine it, we remove the below of number
Below
one.
elements, the row and the column will be removed.
Yes, B.
Correct.
Yes, B in front of AB and C in front of CA and minus and when we make the determinant of A, we remove the below of A and we choose A in front of AB and A in front of CA plus and the second and the third one BC. When we want to make it, we remove the below of BC and we choose one in front of C and B in front of A. And after that, we minus and times all of them, and we can conclude it.
Okay, that's very good. Now, I will tell you. I will repeat the same thing. What I did, what he said. Remove this, pick this one. This one is over here. Remove this, remove this. You are left with this. It's written over here. First one is plus, second one is minus, minus A here. Remove this, remove this. You are left with one CA, one AB. Okay? First one is plus, second one is minus, third one is plus. Now, with this BC, remove this, remove this. You are left with one B, one C. Okay? Now, Any number which is multiplied by 1 will remain the same number. Okay. So forget this one now. Multiply this diagonal top to bottom. This will become AB square minus AC square. Okay. Here it is. Minus A. Keep that thing in your mind. 1 into AB will be AB. AB into A will be A square B minus this minus and this minus will become plus, and this will be this AC, that will become A square C. Okay, plus BC. 1 into C, that will become 1 into C is C. BC into C is BC square plus minus B, that will become B square C. Okay, now what I will be doing, I will be just clubbing these numbers. Listen to me what I mean to say, why I did that. I'm doing this thing this time. I'm just clubbing numbers together so that I can get something common. What I will be doing, I will be clubbing AB. First of all AB, then BC, then AC. I just club them, this part, this part, this part, and this part. How many are there? 3, 3, 6. 3, 3, 6. Take out a common, you are left with B minus A. Here you can take BC common, you are left with C minus B, plus you can take, okay, this is something extra. You take AC common, you will be left with A minus C. This is extra, this is not required. This is, these 6 values will be there. Okay, so then this step will come. Further, we cannot solve it, so we will be leaving the answer over here. Okay. Now comes properties of determinants. Somebody said they have studied this. I was happy that you remember it. Now actually that part will come. You were talking me about matrices, and we are just that those are determinant is matrix. The matrix is array, and determinant is its value. That is the only difference. Now we will be talking about properties of determinant. First one is minor and cofactor. There is a minor difference between these. Minor of matrix A is written as Mij. Don't change the order. Don't change the notification. Otherwise, it will be problem for you to understand and to recall it. Just have a look what I am telling you. Mij. Always remember, first row comes, then the column comes. That is the by convention. Mij means ith row and jth column. What is cofactor? Cofactor, there is a trick of doing it. What I have written in the box is the standard formula, but there is a trick of doing it. Now the question arises how to determine the minor and cofactor of A11, element A11. What I will be doing. See to it. Same thing I'm doing. Just pick up the 4 elements. Which are the elements? If I'm talking about this minor of A1, remove this, you are left with this. Here it comes. Okay, solve it, you will get a number. After multiplying diagonal this minus this, you will get a number. That is the minor. Now we have to calculate the cofactor. The simplest method of remembering it, when you are going to add this 1 plus 1, you will get an even number. And when you will be Multiplying a negative number even times, you will get plus sign. Minus 1 raised to the power 2 will be 1. Is that correct? Minus 1 raised to the power 2 will be 1. Minus 1 into minus 1 will be 1. This is the basic thing. Now, here it comes. See, I have taken a 2 by 2 matrix and I will be calculating all the cofactors and minors. First of all, for the minor of this, A11, that is minor is M. M11, remove this you will be left with 5. M12, 1 and 2, you will be left with 2. M21, remove this, you will be left with minus 1. M22, remove this, you will be left with 3. Okay? Now, what I told you, add this 1 plus 1 is 2. Minus 1 raised to the power 2 will be plus 1. Plus 1 into 5 will be 5. Here it is. Now this is an odd number. 1 plus 2 is 3. 3 is an odd number. Just place minus in front of this number. Here it is. Third one. This is 2 plus 1. 3. Odd number. Remove this. 1. 2 plus 2 is 4. 4 is an even number. The sign will remain the same. What you saw over here. This is the answer. This is the theory part. And this is what I told you. Add these two numbers. 1 plus 1 is 2. 2 is an even number. Sign will not change. 1 plus 2 is an odd number. Sign will change. Sign has changed. 2 plus 1 is again an odd number. Sign will change. Sign has changed. 2 plus 2 is an even number. Sign will not change. Sign is the same over here. So these are the minors and these are the minors. Have a look at it, go through it, and then tell me whether it is okay for you or not. I had already told you every one of you should have a paper and pen with you. That will be easier for you to understand. Should I repeat it or should I move further? Okay, fine. Now comes, okay, that's great. Now comes the properties of determinant. Here, what comes, listen to it very carefully. First of all, the first property is the value of determinant remains unchanged if rows and columns are interchanged. Value of the determinant will not change if rows and columns are interchanged. See to it. Rows have been changed with columns. This was the row. I have just put it over here in the column. This was the row over here. This was the row here. Earlier determinant was A. Now it will be A dash. It will remain the same. Suppose if I open this determinant and if I get a value of 2, after changing it, I will again get the same value, that is 2. Now, if any two row or column of a determinant are interchanged, then the value of the determinant is changed by a minus sign. In the earlier problem, I had changed everything. In the second one, I am changing only two rows with two columns. You can see the matrix, and row 2 has been changed to row 1. What it will be? If the earlier determinant value was 2, after changing the rows and rows with column, you will get minus 2. Third one, if all the elements of a row or column is multiplied by a non-zero number k, then the value of the new determinant will be k times the value of the original determinant. What I mean to say, if I had multiplied this with a non-zero number, that is k. So what it will be, take this k out and remaining will be the number. Keep one thing in mind. Don't make it k cube or 3k. Don't make it 3k or k cube. It will be a single k only. K over here. Suppose the value here was 6 into 4, 24, and your number was k. K is 4. So this will be 4. Here also, dear learners, please mute yourself. Sometimes it becomes very difficult for the others, even for me, even to concentrate on what I'm saying. Now, see, if I'm
Sarah, 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 please mute you or mic.
Rehana,
No.
please mute
Oh,
yourself. Here again, we can take this. It can be written like this. Suppose if I'm taking m common, m by m will be 1, and we will be remaining with the original matrix. Okay. Now, if each element of any row or column consists of two or more terms, then the determinant can be expressed as a sum of two or more determinants. What I mean to say, just have a look at the problem. Here. Here you can see. Rehana, please mute yourself. What I will be doing, I will be picking this element. This, this, and this, and this. Plus sign because here it is a plus sign. I will be taking plus, and what is left now? X, Y, Z. And the third one will be C1, C2, C3. Third one will be. That means this has been split it up into two. Okay. Now, first one is the value of a determinant is unchanged. If any row or two column is a multiplied by a number and that added to another two or row or column. Please see over here. This was the original matrix. What you have multiplied? You have multiplied C2 by M. That means complete column will be multiplied by M. And you will be subtracting column 3 by column 3 after multiplying it with N. So what you will do? Every element of C3 will be there. This is what, how this has been expanded. It's not reduced, it's expanded. Because these all are the things what we will be doing in solving the matrix and getting the solving the determinant and getting its value. because otherwise it becomes very tedious to operate. Now comes. That is the now same thing. Listen to it very carefully. One of our learners said, if any two or row or columns of a determinant are identical. Now just tell me which row or which column is identical. Then the value of the uh, then its value will be zero. Which row or which column is identical? See, have a look at very carefully. Which row and which column is identical?
Sir, I can. It can be any row or any column.
But my question is over here in this problem, in this slide, first column, second row. First column and second row. Where is the first column? This is the first column. And where is the second row? Second row is the same. Nobody can tell me which row and which column are identical.
In question number 6, I think first row and third rows are identical.
That is that much simple. Now here you can see A1, B1, C1, and in the third one you can see A1, B1, C1. These two are identical. That is why value of determinant is zero. Simple. Thank you. Then comes your seventh one. If each element of a row or a column of a determinant is zero, then the value will be zero. Okay. Now, all elements are zero, but only diagonal is there. All elements are zero, but the diagonal is there. So its answer will be ABC. Okay. Now, following are the notations to evaluate a determinant. Ri to denote with Rith row. R is for row, C is for column. If you are changing I by J, so you have to put this arrow. And if you are adding, first of all, you are multiplying with any number, that is lambda, and you are adding it. So that means your row 1 will be equal to row 1 plus lambda times of the another row. And whatever we will be doing in a row, similar operation can be performed in a column also. Now keep one thing in mind. Don't mix row and column in a particular problem. Operations with row will be done in a particular problem, and operation with column will be done in a particular problem. Don't mix row and column together in a problem. If A is the determinant of order 2, then its value can be easily found. But to evaluate determinant of a square matrix of highest order, we should always try to introduce zeros at maximum number of places. Remember this, what I'm telling you right now. I'm repeating it. If A is a determinant of order 2, if A is a determinant of order 2, that means it is a 2 by 2 matrix. Its value can be easily calculated. But If it is of a higher order, that means we will be maximum, we will be going for 3 by 3 matrix order. If that is, so in that case, we have to try to introduce zeros at maximum number of places in a particular row or column by using properties of the determinant, what we have just discussed. Now we will see how they are applied. Remember this form. This I have done just right now. If it is a 2 by 2 matrix, multiply these two, subtract these. If you are opening a 3 by 3 matrix, the first one is plus, second one is minus, third one is plus. That was I was doing across column. If somebody wants to do it across row, the same thing will be there. First one is plus, second one is minus, third one is plus. I request everyone to follow this method because it is an easier method and conventionally accepted everywhere. Open by this method. First one, I told you first one is plus, second one is minus, third one is plus. Now here it comes. How properties of determinants are applied to solve a particular problem. Okay, now this is the problem, and you are being asked to prove that this is equal to this. I told you a minute back that in a matrix, in a determinant basically, you have to make maximum number of zeros. Now what I will be doing and how I will be doing. That is the question. What I will be doing and how I will be doing. I will just keep an eye on this part. I will be doing operations on this part, and I will be keeping an eye on this part. It was told to you in the theory that you have to make maximum numbers of elements at 0. Okay, I can see over here, this column has every element as 1. I will try to make 2 elements out of this 3 as 0. Now the question is how I can do that. What I will be doing, I will be subtracting this row 1 from row 2. I will be making this 0 and this 0. I will be performing 2 operations in a particular step. First of all, what I will be doing, I will be making this as 0. This as 0 can be made as if I'm going to subtract these 2. And after subtracting, what is the step? How to write it? Now we will say by applying row 2 tends to R2 minus R1. Stop it over here. R2 tends to R2 minus R1. Subtract every element of row 2 from row 1. 1 minus 1 is 0. B minus A is B minus A. And B square minus A square. B square minus A square. In the same step, I will be reducing this to 0 again. So what I will be doing, R3 tends to R3 minus R1. Okay. 1 minus 1 is 0. C minus A is C minus A and C square minus A square. Okay. Now, here, it is A square minus B square. This is the property. I will be splitting this. A square minus B square as A minus B into A plus B. Straight away. Keep it over here. When you will be solving this, what you will be getting? B minus A into B plus A. Take this B minus A common. From this B minus A common, you will be left with and here you will take C minus A common, so you will be left with this. Now what I will be doing? I'm taken B minus A from row 2 and C minus A from this. So what is left over here? Okay, this is a typographical error. This is A. I will be taking this B minus A from B minus A common to here. This is B minus B plus A, and this is C plus A. Again, what I will be doing, I will be taking this and I will be opening now. When I will be opening, so what I will be taking, I will be removing this and this. I will be left with one B plus A. It is not B plus C, it is B plus A. It is written over here. And this is C plus A. So this is C plus A. I will be opening it now. 1 into C plus A is C plus A minus 1 into B plus A. This is here. Open it up. What will be removed? You will be left with this plus and this plus will get cancelled. You will be left with B minus A, C minus A, and C minus B. This is what you were asked to get. This is B plus C, not this is B plus A, and this is C plus A, because we have taken B minus A and C minus A common. Is that clear now? Now comes your Cramer rule. Now here we will be having two equations, and we have to find the value of x and y. This is a 2 by 2 matrix. Listen to it very carefully how this transformation is done. Now see to it. This is a 2 by 2 matrix. I will be applying Cramer rule. Cramer rule is basically applied to calculate the value of the variables. These are the two equations. Ax plus by is equal to E, Cx plus dy equal to f. We have to calculate the values of x and y. Now, what we will be doing? First of all, for x, we have to find dx upon delta, delta x upon delta. And for y, we have to calculate delta y upon delta. This is the formula. Now the question arises, what is delta and what is delta x and what is delta y? Now see to it very carefully for delta. Pick all the elements of this as it is given to you in the problem. Right away we will be picking AB and CD. Okay, this is delta. For delta x, what we will be doing? We will be replacing AC by EF. AC by EF. So it will become EF and BD. This is for x. For y, what I will be doing? I will be replacing this BD by EF. Here it comes. And then you have to simply multiply it. You will get a number over here, number from here, and number from here. Apply it. This method is only applied when delta is not equal to 0. If it is 0, we cannot use this number, because 4 divided by 0 is infinity. This is applied only when delta is not equal to 0. I'm just repeating how it is solved. First of all, write A, B, C, D in the same order. For delta x, replace this AC, because these are the coefficients of x, by these constants, EF. And similarly for y, replace this BD by these constants, EF, and solve it. For a 3 by 3 matrix, what will you be doing? These are the coefficients, original form. Okay. For B1, yani for delta x, what I will be doing? I will be replacing these by B1, B2, B3. Here it comes. B1, B2, B3. A12, A13, B22, A23, A32, A33. Okay. Similarly for delta x2, what I will be doing? I will be replacing this with B1, B2, B3 replaced. Here you can see. And for the third one, I will be replacing this by B1, B2, B3 replaced. I will be getting 4 numbers, one here, one here, one here, one here. I have to calculate x1. x1 will be equal to delta x1 by delta. x2 will be equal to delta x2 by delta. x3 will be equal to delta x3 by delta. Again, the same thing applies. Delta should not be. Any question? We will be doing it. Okay. So I will be solving the problem first of all in mathematics. What happens? A theory is taught, logic is taught, and then a problem comes. Here it comes. Have a look at it. Yeah, I have to apply Cramer rule. This is a 3 by 3 matrix. Pick up the coefficients. First step. Pick up the coefficients. 1, 2, minus 3, 2, minus 1, 4, 4, 3, minus 4. Open it up. I hope you people are doing it. The solution is written in front of you. Just let me know where the problem is. 1 into minus 1 into minus 4 is 4. 4 minus 4 into 3 is 12. First one is plus, second one is minus, minus 2. You will be left with 2, 4, 4 minus 4. That will be minus 8, minus 16. Bracket close. First one is plus, second one is minus, third one is plus. Plus into minus 3. That will be 6 plus 4, 10. Okay, that is clear. Dx. What I'm doing? Replace this. See to it. Replace this 1, 2, 4 by 0, 10, 6. Replaced. Rest everything will remain the same. In dy, replace this column by 0, 10, 6. Open it up. Any number multiplied by 0 will be 0. Third one, replace this with 0, 10, 6. This is the complete solution of the problem. Okay, now x is dx by d, that is 20 by 10, that is 2. Y is dy by d, that is 20 by 2, 2. And z is dz by d, 20 by 10, that is 2. Your answer is this. Now the thing is that how I know that this answer is correct? How you will come to know that this answer is correct? Your answer says x is 2, y is 2, z is 2. Put it over here in any of this equation. Any of this equation. Put x is equal to 2, y is equal to 2, and z is equal to 2 in the left hand side and see what you are getting. Simply place x equal to 2, y equal to 2, and z equal to 2 in equation number 1. What you are getting, just let me know. Put x is equal to 2, y is equal to 2, z is equal to 2 in equation number 1. Let me know what you are getting. Thank you. Anyone else? Now put that in equation number 3. Put x is equal to 2, y is equal to 2, z is equal to 2 in equation number 3. Right, 10 कहाँ से कैसे आएगा? How you got 10? I said put x is equal to 2, y is equal to 2, and z is equal to 2 in equation number 3. Okay, that means our answer is absolutely correct. This is the way of checking up your answers. This is the way for checking up your answer, and your answer technically ends over here by writing this. Therefore, the solution of the system x, y, z, this is the right way of representing your solution. That was the confirmation what we have done. We have calculated the value of x is equal to 2, y is equal to 2, and z is equal to 2. We just want to confirm it. whether we have done it correctly or not, straight up. Go back to the problem. In any of the three equations, you can write these values and see what you are getting. If you are getting the same number, it is correct. I will be moving further. Another tedious problem to calculate the determinant of this problem. Just let me know, is there any error in this solution or not? I just want you people to let me know whether there is a problem in this solution or not. And if it is there, then where is the problem? The complete solution is in front of you. I've taken this problem because there are few elements with minus sign. The method is not going to change. I just want to let you know, you people to let me that where is the error in this solution. Yes, please ask the question. You are free to ask the question. Who has raised the hand? Please ask the question. You don't have the question? Is the slide not visible to you? You can't see the slide.
All the people mentioned their questions on message board.
I just want to know, somebody has written, I don't have the question, I don't understand. It is very much in the slide. The problem is here. The problem is here and the solution is here. I've just asked you, is there any error in the solution or it is correct? It isn't correct. Then where is the problem? Why it is not correct? Just let me know.
Can I say, sir?
Sorry?
Can I say why
Please,
it's
please. I just want to know. Where is the problem?
okay? Yes, the first one here, 1 into 1,
Huh?
1, and 4 into -2, it becomes -8, not +8.
Okay, fine. But what does the theory says? What I had been teaching you? This is why I have created this problem. 1 into 1 minus this into this. Then minus into -8 will be +8. Minus 142. अरे भाई 142 कैसे हो जाएगा? You got it or not? What I taught you, this diagonal multiplied minus this diagonal multiplication. So what will be? 1 into 1 is minus 1, minus 2 into 4 will be minus 8. Minus into minus 8 will be plus 8. Then how do you got this? Second one. 7 minus 2 into minus 3 is minus 6. 7 minus 6 is third one. 7 into 4 is 28. Minus 3 into 1 is minus 3. Minus 3 into 3 minus is plus. So 28 plus 3. Is that clear now? I know it. This is the problem. I know it. Nothing to worry about it. I just want to discuss it. This is the actual way it was, why it was these maximum numbers of minus signs were taken. That means the answer is minus 140. Is that clear? The answer is minus 140. Or somebody has doubt? These are the problems which normally learners do.
Yes, sir. Yes, we got it.
Got it? Thank you. Now see to it what I am doing. The number is a very big number, 42, 1, 6, 28, 7, 4, 14, 3, 2. Numbers are too big and it will be difficult for me to evaluate its determinant. So what I will be doing? I will be applying the properties now. What I will be doing? I will be splitting 42. There is no need of splitting 42 by 1 in terms of 1, but it's better to multiply split 42 in terms of 6. It will become 6 into 7. Similarly, 28 can be broken as 4 into 7 and 14 can be broken as 2 into 7. What I will be doing? I will be picking this 7 away and I will be left with 642, 173, 642. Two columns are same. If two columns are same, then answer will be I have splitted 42 in terms of 6. So what I did, what I got, 6 into 7, 28, 4 into 7, and 14, 2 into 7. 7 can be taken out, left with 642, 173, and again 642. You can see that their two columns are identical. If two columns are identical, then what happens? If two columns are same, the determinant becomes 0. That is why the answer is 0. Correct? Okay. Now just solve this. Somebody wants to. It will be 0. Correct. Now, dear, I'm not going to show you the solution of this problem. Let me know what does it comes. What to do with this?
first column we can take 2.
2.
Count.
Okay. So it will become 2. That means you mean to say that you have to split. You will be splitting it as 2 into 3. Or you will be taking 2 common, so it will become 3, 1 minus 5. If you are taking 2 common from column number 1, so it will become 3, 1 minus 5.
Sir, can we take minus 2?
Yes, you can take minus 2. What will happen then?
Okay, we will take minus 2 and the determinant will become 0 and the answer is 0.
You want to do that? Do it. Do it. I don't have any problem in that. That's good. There is no need of raising a hand. Just ask the question. What was the question? Why somebody raised his or her hand? One of your learner said take minus 2 common. I said okay. If you are taking minus 2 common, so this is the solution. By taking minus 2 common, what will happen? Column number 1 and column number 2 will become identical. As they become identical, answer will be reduced to 0. Is that correct? Now, another problem. Yes, please. What is your question? वाहिदा जी आपका क्वेश्चन क्या है? Now the thing is that what I'm going to do. You can see that the problem was given to us as 1, 1, 1, ABC, BCA plus B plus C plus A plus B. Different things will come into your mind. We can apply or we can reduce these elements at 0, or we can split these, because you have seen we can split it. But what I want to tell you, see to the problem very carefully. After seeing the problem very carefully, what I found, if I add column number 2 with column number 3, so it will become A plus B plus C. Second one will also, after changing the position, we will get A plus B plus C. And similarly, in the third, we will get A plus B plus C. We can take A plus B plus C common. What we will be left? We will be left with 1. The column number 1 and column number 3 will become identical. As soon as they become identical, the answer will be reduced to 0. Is that correct? That 3 options will come under your mind. First one is, as you have done, you will be trying to reducing it to 0. Other one, you have seen that we can split this But what I'm asking you, add this. As soon as you will add, you will get this. This will take this common, and you will see column number 1 and column number 3 will be identical. If two columns or two rows of any determinant are identical, its value becomes 0. Is this correct? Somewhat tedious problem. Normally, these are the problems which one should be in a position to simplify. Straight away, this will be the problem given to you. A, B, C, A square, B square, C square, BC, AC, and AB. It's very difficult. We cannot take any. First of all, what happens comes into our mind. First of all, we will try to take something common so that it can become identical. It's not possible at all to take either A, B, or C common from any row or column. What we will be doing? Another thing which comes into our mind. If the problems, listen to it very carefully, if the problem is related to some squares, so that means there is an indication of subtracting, because you know the formula of a square minus b square, that is a plus b into a minus b. As soon as that thing clicks into your mind, you will see that you will be in a position to get something common from all the row, or from the row or from the column. Now what I'm doing, don't forget to write this line, because when you will be applying this, then only you will be getting this. This is compulsory, mandatory in writing before you get this. So what I will be doing, I will be subtracting column 1 to column 2, C1 minus C2. And similarly, I will be doing column 2 tends to column 2 minus column 3. Once it is done like this, so we will be getting this part. Again, I have missed a step over here because I've already splitted it. A square minus b square is a plus b into a minus b. And b square minus c square is b minus c into b plus c. What I will be doing, as you can see, here something is common. I will be taking this out. I will be taking this out. I will be left with this. Okay. Now question arises. Still, it will be tedious job to solve it. But further, what I will be trying to do. It was told to you, there is one option. Try to make as much as numbers elements at 0. What I will be doing, I will be making it 0. How? I will be converting this to 0. Or you can convert this to 0. That doesn't make any difference. Either you subtract C2, C2 tends to C2 minus C1, or you can perform C1 tends to C1 minus C2. What I have done, I have performed C1 tends to C1 minus C2. After subtracting, first element will become 0. And in solving this, what will happen? A minus C, and in the bottom it will be minus C plus A. I will be taking minus common, and I will be removing it. So I will get A minus B into B minus C into C minus A. So I will be left with 0, 1, 1. What I will be doing, again I will be making one element 0. So I will be converting that row. Row 2 tends to row 2 minus row 3. Row 2 tends to row 2 minus row 3. So this will be performed. As this will be performed, the two elements are 0. In column 1, two elements are 0. So I will be opening it along C, third one. Open it. You will get this answer. C square minus AB minus AC minus BC minus C square. Take anything common, C square minus C square gets cancelled. You are left with AB plus BC plus AC. 3 to 8, once again. Here it comes. First of all, what was supposed to be done after seeing the problem? Because here, normally what happens, what has to be proved is given. I have deliberately removed what has to be proved is shown to you in the problem. Because I just want to make you understand how the concept works. First question, first part is try to take anything common. We can see that nothing can be taken as common. Second thing, what was told to you, that if the squares are there, then try to subtract something from something. Because why? Why subtraction will be done? Subtraction will be done because you will be in a position to convert that into A plus B into A minus B. So what I did, C1 tends to C1 minus C2, and C2 tends to C2 minus C3. Here I am doing that transformation across column. As soon as that is done, I will take something common. What can be taken as common is taken common. A minus B is taken common. You are left with this. Again, the question arises. Still, it cannot be opened. But what the theory says, you have to make maximum elements at 0. So here, 1 and 1, one element can be made 0. Subtract it. After subtracting, you will get this. Take something common. Whatever is taken common, take it common. After taking up the common part, you are left with this now. Here you can see that there are two. 1 is there. Subtract it. Reduce it. Now here this time it is in row. Earlier it was in column. Now it is in row. Subtract it. After subtracting, open it. Have you understood it? Should I move forward? Now see the mixture. Whatever is being done is done for a cause. Two, three things will come across your mind. Now see to it. Here in this, you have to prove it, and what has to be proved is given to you on the right hand side. That means after solving this big problem, you have to get an answer as x cube. Now, how much interesting it is. You will say that, okay, we can do one thing. I will ask you what you can do. You will be saying that we can take X common from column 1 and column 2. Because I will be saying, okay, then what will be there? You will see that it will be what 2, 3, 4, 1, 3, 6. Still, the problem is not solved. What I will be doing, I will be splitting this into two matrices. 3x plus y has been broken down as 3x and y in the other one. 4x and 3y in the other one. 5x and 6y in the other one. Rest all the elements will remain the same. What I will be doing? Now take out common. After taking out common, what is left? 1, 3, 6. I'm not touching the first one. I had taken this y common, x common, x common. It becomes x square y. You are left with 1, 3, 6, 2, 3, 4, 1, 3, 6. These two are identical. Remove this part. Okay, now you are left with this. Here, can anyone tell me what can be done? You are left with this now. This has been removed. This one. Any one of you who can tell me what can be done? No idea. Have a look at it, no worry. Any idea from anyone what can be done now? I told you that we are left with this part only. This has been removed. This is left. How this can be reduced at 1?
Sir, we can reduce X and Y.
X and Y where? I told you this has been removed. You are left with this one now. This has been removed because these two columns are identical. So that is why this has been removed. I'm just worried about how this will be solved. This has been made 0 because two columns are identical.
Sir, we have 3 common.
With 3 columns. Where?
And-
Where? Common doesn't. Where? In which part you are saying that 3 is common? Common means that whole element, whole number has to be present in all the elements of a particular row or a particular column. I've told you that this and this are identical. That is why this part has been removed. As this will become 0, it is written over here. I'm telling you, you are left with this. I'm just asking you now what to do with this part. Any idea from anyone? लीजिए, अब देख लीजिए। यहाँ is here in this problem, you have seen that these were the numbers. Again, I have applied column transformation to simplify it. And after simplifying it, what I found that still in a column I'm getting 1, 1, 1. So it's better to reduce it to 0, because the theory itself says try to reduce maximum number of elements as 0. And in the last step, open across column 1, because in that particular row and in particular column, 2 elements are 0. Is this clear? I am audible to you? Have a look at it, what I've done. Earlier, 2 columns were same, so they were reduced. You are left with this. What I am doing, this is simply simple application of it. You can see if subtracting can be done, so this can become 1. 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. What I did, I subtracted. Column 1 tends to column 1 minus column 2. As soon as that was done, this was reduced. As this was reduced, try to make maximum numbers as 0. So I normally make this subtracting R1, R2 में ट्रांसफॉर्म करिए, R2 minus R1 and R3 tends to R3 minus R2. ये ट्रांसफॉर्म जब आपने किया तो ये 0 बन गया, और जैसे ही ये 0 बने, स्प्लिट इट, ओपन इट. जब आप इसके अक्रॉस ओपन करेंगे तो एक ही चीज आएगी, 3 minus 2, बाकी सब 0 होंगे. 3 minus 2 is 1, और x cube आपका बाहर है. X cube into 1, it will be 1. Is that clear now? लीजिए. Now comes omega. Prove that this is equal to 0, where omega is cube root of unity. Cube root of unity means omega cube is equal to 1. Now what I will be doing? What is being done? Omega 5 can be broken as omega 3 into omega 2. As the powers the coefficients are being multiplied, powers will be added up. So 5 can be split it as 3 into 3 plus 2. So omega 5 can be written as omega cube into omega 2, omega square. Later on, what you can do, wherever it is, split it. Omega 4 can be split it as omega cube into omega. And omega 5 again can be split as omega cube into omega 2. Omega cube is 1. Okay, omega cube is 1, so it will become 1 omega square, 1 omega, omega square 1. Column 1 and column 2 are identical. Omega cube, omega 5 can be written as omega square into omega cube. Omega 4 can be written as omega cube into omega. And omega cube is equal to 1 because omega is the cube root of unit. Got it? Now have a look at the problem. I will tell you now how to solve these types of problems. The problem is given to you and you are being asked to prove it. Just have a look at the right hand side. What is given to you? It is x square into x plus a plus b plus c. And when you go back to the problem, see to the problem, can this big bracket x plus a plus b plus c can be obtained by any transformation? Why I am thinking of doing that? I am trying to do that because if I get by any operation, transformation, something common as x plus a plus b plus c, it will be easier for me to solve the problem further and I can easily get x square. What I did, going back, what I can do, I simply thought, why not to add all these elements? Before writing, it has to be calculated into your mind. If I am going to add all that, suppose I'm transforming column 1 as summation of column 1 plus column 2 plus column 3. So straight away I can see that it will become x plus a plus b plus c. Take that common. Now, once that is taken common, so you can see that you have got this part. Now the problem is of getting this. This has been obtained. Mathematically, what we can do, we can reduce these twos as 0. I will be doing here, reduced. Reduced. As soon as this is reduced, straight away I got these two elements. Maximum number of zeros bang gaye. You got maximum number of zeros. Okay, open it. जब यहाँ सारे जीरो हैं इसको छोड़ के तो आपका डायगोनल का ही आंसर आएगा x square. Got it? I'm going back. Have a look at it. What came into your mind? What is what has to be done. Try to think of getting this part as early as possible. X square can be calculated anytime, but this is what has to be solved first. So going after seeing to this problem, I thought ki add all these columns. As soon as these are done, so this is done by this way. We have to write applying C1 tends to C1 plus C2 plus C3. You get this part. Straight away take this column. Here 1 1 1 B x plus B B C C x plus C. Okay. Now reduce these two. These two to 0. Reduced. Row 2 tends to row 2 minus row 1 and row 3 tends to row 3 minus row 1. As soon as this is done, you will get 4 elements as 0 down the line in column in row number 2 and row number 3. Once you open it across 1, you will be getting x squared. That's it. Rest everything will be 0. And what is required to it? What was the question? X squared into x plus a plus b plus c. And you have got it. Now, any question from anyone?
No questions, sir. Thank you, sir. From my side.
Okay. Good. Anyone else? I hope there are 15, 16 learners are there. What is their opinion? How do they find it? As far as this part is concerned, it is a recorded session. It will be posted to you on your LMS or it will be posted to you by the officials.
Okay, sir. That is a good idea. We will achieve
It,
it.
it will be, this is
very
a recorded
easily.
session, nothing to worry. The thing is that how to study mathematics. First of all, have a copy and pen with you. Concentrate on what I'm telling you. This is a recorded session, so you will get everything. Next part is next time we will be meeting on 10th. In between, you just have a look at this video and try to solve some problems. It will be easier for you because next time I will be expanding it. The whole application of matrix determinant 1 and 2 will be there. In that, for that you have to just go through the study material. Try to do it. If you have any problem, just write it down on a piece of paper, and when I come next time, just ask me that this is the problem. Please solve it. So definitely I will do it. Okay, so shall we conclude today's session? I hope you might have enjoyed and learned so many things today. Okay, bye-bye.
Thank you so much, sir.
Thank you.
Have a great.
If you have any problem, just write it down and let me know in our next meeting. I will try to solve it.
Thank you, dear teacher.
Thank you.